uh, data is a collection of, let's say, numbers. It can be pictures, it can be anything, whatever we can think of. Now, collecting this data into some storage that can be used, named as database, then querying on it, we can ask several questions. Let's say if we have got a collection of, let's say, name of the students with their roll numbers, we can make query. So like, if we can say, we want to say, ask what is the name of the person who is on roll number 10. So we can start a query and we can run on it on the database, and we can fetch results. The results we are fetching after the query is known as processed data, or can be called as information. When the data is transformed into information, we can make decisions on it. This whole thing, from collection of data to the query to processing and then to decision making, comes under the umbrella of information system. Now, what is a system? System is used for capturing, storing, updating, manipulating, analyzing data. So we have discussed this. Now, information system is, for example, we can say library management system, or college management system, or school management system, hospital management system, or it can be an ERP of any kind used by large enterprises for managing their own data and making query on it, getting information after queries, and then making decisions on it. Okay. So the simplest form of information system can be a telephone directory. We've been using it long back in the 90s. Directories were there. Whatever, whenever we want to know some number, phone number or something, we would query it. Now, what is GIS? When we attribute geographic positions to any information system, then it becomes a geographic information system. Uh, it can be said that if we can attribute any geography to a data, then it becomes geographic data. In simple language, we can say, whenever we query where, the term where, when we ask question where from a database, then it can be termed as geographic data if it can answer our question of where. So geographic attributes, geographic positions attributed to any data system or information system will result in geographic information system. In geographic information system, we can capture, store, manage, analyze, display geographically referenced data and information. Geographical reference means we have to have some position attributed to a data that can be queried for answering our question where. Now, this can be a user interface for geographic information system. Like, uh, there can be maps with various indices, like transport can be there, roads can be there, hydro dam can be there, various information can be there stored in the database, and we can query, like how far is some one place from the another place, or um, we can query what is the area of the inundation a dam is creating in its upstream, or we can say uh, like we can run a query if a dam is, let's say, gates are open, how much area would be flooded post monsoon in the downstream. These queries we can run easily on geographic information system, as these questions are related to civil engineering. So as civil engineers, we can ask this question with the geographic information system, and easily it can easily answer our queries. Now, definition of a GIS. Whenever we say definition of a GIS, so simply, or it is nothing but a set of computer programs written in such a way so as to help us efficiently capture, store, update, manipulate, analyze, and display all form of geographically referenced information. Whenever we say geographically referenced information system, it refers to maps. In the most easy language, it will be like an atlas. We used to use in old times atlases. The same atlas can be referred to as geographically referenced information system. So, uh, but the GIS will encompass not only the computer software, it will encompass hardware, software, data, personals who will be working on the softwares and the hardwares, and all the queries we can run on the information system. All these things will come under the umbrella of GIS, or Geographic Information System. So, what are the key functions of a GIS? It will give us the spatial coordinates of each and every object we create in the database. The inputs will be organized in layers. So, like one layer can represent all the roads available in the location or near vicinity of the map. Second layer can be of, let's say, railway line. Third layer can be of the agricultural land. Fourth layer can be of forest land. Fifth layer can be of built up area. So all the data can be is provided in the layered system, so that we can easily query or run a query on the database. Data can be stored and retrieved. It will be there are majorly two types of uh, data models. We will be looking at them in some time, and these are stored in a peculiar format so that attribute data can also be attached to these data, the spatial data. Okay, so queries can be run on the database, and then the analysis can be done based on the various queries. Data can be modified, but then again, modification has to be first done, then verified, so the maintain the data integrity. The data can be viewed. There will be a different screen for viewing the data, which will display all the answers or other the information after being processed, uh, after the query has been run. So we'll get the result of analysis in the window in the form of map, and then we can finally make our decision for whatever which problem we have run the query. Now the geographic information system has got prob- a very well defined process. So first of all, the problem is defined, then the criteria is selected to evaluate the problem, then the data set is built, or whatever data is required to solve the problem. Then the analysis performed on the data set, output is created, and the decision is made. If the decision is okay, then it's good. The process ends there. If it is not up to the level, then again we repeat, or rather it reiterate the whole process as and when required. So there are two types of data in geographic information system. One is spatial data, the other one is non-spatial or attribute data. So spatial data is where we can attribute geographic coordinates to the objects, various objects or entities, like latitude, longitudes, or XY coordinates, whatever is either Cartesian coordinates or the GPS coordinates, like latitude, longitude, are attributed to the various objects in spatial data. Non-spatial data is, or rather attribute data is called data about data in the very simple terms. Like if there is a land parcel, which is a polygon, so we can have ownership records, like who owns that land, how much area is in this, what area is it being represented by that land parcel, where is that land parcel located, is it irrigated by a canal, or not irrigated by a canal, or by some other means is it irrigated. So these all information can be recorded as attribute data, and it has to be linked with spatial data. So again, uh, spatial data can be of two types: raster data, vector data. So here we can see the real world as it actually is on the ground can be represented by vector data or by raster data. So two models are there to represent spatial data in GIS. One is raster and the other one is vector. So both of them are important. Both of them serves different purposes, and they have got their own merits and demerits over each other. So when you want to, which one you want to use depends on the particular problem you're going to address. So raster data is represented as a grid of pixels. Pixels is picture elements. Pic- each picture elements has got its own digital number or digital value, which comes from the reflectance of that particular cell, and it can be viewed as a matrix of each picture element aligned its in its own position and has got relationship with the other picture element based on the position it is in. So if you want to correlate it with, you can correlate it with LED TVs, or LED screens you've got. LED screens have got picture element, each pixel, very small, fine pixels, uh, which illuminate and create pictures, so you can watch different programs on it. So it is the same. It can be stored as GIF, JPEG, TIFF, GeoTIFF, MRSID, JPEG, or IMG. These are the formats in which raster data can be stored. Now, this is the raster data model. Here, you can see the real world can be represented as colored pixels in this way. These are linear objects which are represented by pixel in this way, and these are point objects which are represented in this way. These are polygon objects which are represented in this way. Now you can see each pixel has got a value and an attribute which is attached to it. Like this value is 1, and the attribute data is day 1, value is 2, day 2, value is 3, day 3, and value is 4. And these days represent spread of fire. These are rows, these are columns, and in raster image, the number is as in matrices, the numbering is done from the upper left corner. The cell size decides how fine the picture will be. The more the number of cells, the finer the picture is. As an LED, like we know. Now comes the vector data. In vector data, all the spatial elements are represented either by a point or line or a polygon. And each point, line, and polygon has got a Cartesian coordinate or xy to represent its location. Point, as we know, has got no length, so just a coordinate xy will do it. And line will start from a point, end to a point, and will cross many points through its through it, and it will have a length. So it will have a starting point, ending point, and length attributed to it. A polygon will have many points throughout its edges, and will have got an area and a perimeter attributed to it. So these can represent real life shapes in a very finer way. It's like the how we draw a map on a paper. The vector data is like we draw maps on paper, and raster data is like if we take a photograph of an area or something, it will be like raster data will be like a photograph. Vector data is saved as in DWG, DXF, SHP, SHX, or DBF and tab formats. This is how the linear elements represented in vector data. The point elements are represented in this way, and polygon entities are represented in this way. Latitude, longitude are the reference grid for vector data. These are the various elements used to represent the vector data: point, lines, and polygons. In vector data model, points are saved as xy, a single node with no area. Lines are saved as x1, y1, x2, y2, point 1, point 2, point 10. The connection of nodes beginning with to and ending with from. It will have length as an attribute to it. Polygon again, x1, y1, x2, y2, from wherever it is being traversing the area. It will have an area and a perimeter as attributes. Now comparing the vector data model and raster data model. In vector data model, the volume of data will be very less as compared to raster data, because raster data will have a large number of cells, will and each cell will have some value, whether it is of any use to you or not, it will have some value. Whereas vector data will only store the information or data whatever you want to provide or you want to use in the analysis. Vector data capture is slow. Vectorization is a very slow process. You have to digitize each and every point, line, or polygon either manually or automated. Processes are there, but they are not very reliable. So manually, it will take uh, much time. Whereas raster data, you can scan, you can photograph, or you can use any other imaging method so as to create data. Vector data map like visualization is provided, while in raster data we get picture visualization in the form of a picture. Overlay operations are difficult to implement in vector. If you want to overlay one layer of the other, it will be a different. Um, it will be a difficult process because of the involvement of various topologies. Topologies is the relationship of the each and every element of vector data to each other. So topologies make the process difficult in vector data overlay operations. Whereas raster data overlay operations are easy and efficient because uh, each cell can overlay each cell of each layer can overlay over the other layer easily and can generate results in a very swift and efficient manner. In vector data, the feature creation and representation is very accurate, whereas this raster data features are lost if because we won't get very sharp boundaries for polygons and all. So the data will be lost, and if the pixel size is very large, then the minute details are lost in raster data. Topological relations can be established in vector data, obviously, whereas topological relationship are difficult to represent in raster data because topologies are the relationship between each element. So it can be very easily created in vector data as compared to raster data. So whenever we are carrying out like network analysis, let's say we want to make a query, if, how far is it, or let's say what is the direction of one city from to the another, it will be easy in vector data rather than in raster data. But however, if we want to represent the variation of temperature throughout a region, then it will be difficult in vector data, but it will be very easy in raster data because raster data continuity can be represented in a very easy and efficient manner. So let's say air pressure. Air pressure can be represented in raster data very easily. Whatever phenomena that are continuous can be represented in raster data very easily, but discrete phenomena can be queried and represented in vector data very easily. So coming on to the next slide, attributes. In raster data, the cell values or digital numbers are the attributes. It can be brightness, it can land cover code, it can be temperature, it can be air pressure, it can be pollution, it can be anything. It can be a groundwater level. So anything that is continuous is an attribute data for raster data model. While in vector data, attribute records location of point or a length of a line or area of a polygon. So let's say if we want to query how much crop area has been cropped under a particular cropping season. So it will be very easy doing in vector data just because all the agricultural lands will be in uh, will be mapped as polygon, and we can run a query to measure the area under which has been cropped under a particular cropping season. So it will be very easy in vector data, and the attribute data here can be area. So this is how the attribute data is saved in the database. So the first one is census districts showing population, and it can be attributed to the polygon which is numbered as 305 or 306 and so on. While hospitals are point data, and it can be attributed to various data like what type of building what type of hospital it is, how much staff is there, and the likewise. So we've discussed this already. Now we can discuss the functionality of GIS. The data assembly, data storage, spatial data analysis and manipulation, and spatial data output. So data assembly, we can gather data for our GIS from multiple sources. We can manually digitize or scan already existing maps, or we can digitize or scan remote sensing data through various sensors. Or we can already have some data in our database which we can use in our GIS. We can get positions from GPS, and these can be used in our GIS, or we can directly enter data through our keyboard, mouse, digitizing table, and the likes. So these are the various sources which can be used for data assembly and data creation in our GIS. These are example of spatial data and attribute data and how they are stored in the database. Like we can create a map, or rather digitize a map, and then this polygon can be stored with its attribute data in the form of a table or a Excel sheet in our database, which can be queried later. Okay. So this is how the data assembly is done. Now coming and data storage is done. Now coming to the analysis. So you will be, or rather, I must say that you will be surprised to know that the first ever GIS analysis was done even before the modern day computers were invented. The first GIS analysis was done in 1854 by a physician named Dr. John Snow in London. There was an epidemic in London. Cholera was spread in London. Dr. John Snow created the whole map. This is the actual map which was created by Dr. John Snow, and he carried out a GIS analysis manually so as to zero down on the source of cholera. As we know, cholera is a waterborne disease, and it essentially spreads through drinking water sources. So he created a map. He pinpointed all the sources of drinking water. He mapped them. He carried out an analysis so as to know the particular source of water which is spreading cholera. He, by examining the patients from which locations they are coming, the number of patients from which location they are coming, he was able to zero down on the water source which was creating the problem of cholera in 1854 in London. The After doing such an analysis and getting the result of the water source, he closed that water source, and the epidemic was see, ceased to spread across London. In, let's say, now it is almost 200 years, 150 years. In such old times, he was able to do this analysis even without modern day computers. And this is a lithograph. It was created by Charles Sheffens. So the applications of GIS. Now, if you can attribute geography to any data, whatever it is, it can be solved using a GIS. You want to map anything which is available on either Earth or any planet or even the stars, they are all mapped as per their locations. Just because of that, we are able to say that the universe is expanding. We know the location of other galaxies as well. So, if you want to map anything, if you can attribute geography to anything, it can be mapped. And if it can be mapped, it can be queried, it can be analyzed, it can be put to some question, whatever you want to answer, and we can get the results likewise. In a likewise, telecoms. Let's say coming to the second, I've written only 17, but it can be n number of applications you can put GIS to. Many are not written here, but we can always count them as well. So, secondly, telecom services. GIS is very helpful for modern day this mobile companies. They are putting up towers, and GIS is very helpful for them. So they are putting tower in such a way so that there should not be any interference. Also, there should not be any blind spots, and for their network to reach each and every spot and to each and every person. So GIS comes very handy for them. They have mapped each and every parcel of land, and they do GIS study for their their network to be very efficient and effective. In urban planning, my PhD was in urban planning. I carried out a GIS study for so as to answer queries related to sightings of various services, like where should we site a STP, where should we site a landfill site, where should where can we site a let's say commercial complex, where can we site a residential area. So these are all these types of studies can be carried out in GIS in a very effective manner. We can build models. Build. Uh, we can even use AI if we have got a large data set easily available to us. So we can create a AI model for decision making. We can do anything. Smart cities. Uh, each and every smart city, what we are because it is in we are in the state of creating these smart cities in India. So we are in the middle of the process, and the thing is that we want our cities to be carefully monitored for each and every. We are putting CCTV cameras. We are putting for uh, in every public places everywhere, so as to create a good society which is crime free. We are putting up speed cameras so that traffic rules are not broken, people are not able to overspeed, and we, we are creating a good data set for various services, locating hospitals, managing routes for hospitals in such a way so that in case of disaster, these facilities are used in a very efficient manner. Fifth one is environmental management. We want to map deforestation. We want to map, let's say, if some pollution is there of any kind. We want to map urban heat islands. We want to compare the temperatures of urban areas and rural areas. We can easily do these in with the help of GIS. Water management, again, we have got we have data regarding underground water tables of each and every district. Even at the sea level, we can map those. We we can use them efficiently so as to uh, make them available even for our future generations. We we can monitor the surface water bodies for pollution, for availability of water, for uh, pollution in such a way that cities and the built up these uh, towns are not uh, polluting the surface water bodies. STPs are available, and the pollutants coming out of the residential areas, institutional areas, and all hospitals and all are being treated well in advance before the effluents being released into the water bodies. We can do this very efficiently. Agricultural applications are huge in numbers. Uh, even these are used in agricultural insurances as well. If farmers are insuring their agricultural products, so these can be monitored using GIS very efficiently. Which crop should be uh, grown in what parcel of land, with these can be queried in GIS. For this, we can provide it the properties of soil, weather condition, and different um things which are availability of this fertilizers and all, availability of water for irrigation, and we can run a query and we can find out which crop will be beneficial for a farmer in to maintain and get a reasonable good product so as to generate wealth. Disaster management again, some part I'd already discussed, but let's say there is some disaster, either natural or man-made. These can be monitored using JS. For example, if there is a flood in an area, so we can monitor that flood by using GIS with data availability from various remote sensing platforms. We can monitor if how the flood will be inundating the area, what parcels of land will be inundated, which areas are in red zone and which are in yellow zones. We can create zones as per the uh, harm flood can make in those areas. So we can monitor these forest fires, how efficiently can the rescue operations be carried out to manage these or rather mitigate these disasters. We can, the health sector, this sector has been using GIS for quite some time now. Not in our country, but in the foreign countries, it has been used. I know these health insurance companies have been using these GIS portals for monitoring and managing health services to each individuals in their areas. For like, if I get an insurance, health insurance from some company, and let's say I need some medical care at some time, and I just uh, call the insurance company, they will arrange each and everything facility for me at my place only. They will be sending some ambulance. They will be using the data, my health data, and they will be sharing it with the doctors. So they are ready for any emergency which is needed for me. Navigation, we are already using GIS for navigation, and I hope each and every one of you would be using Google Maps. So navigation is very easy through GIS. We have to raise queries. Queries can be very refined. So we can use toll roads, toll-free roads. We want to query petrol pumps near me, or so that whenever I'm traveling, I'm not out of gas. So navigation as an application we've already been using for quite some time. Uh, I remember in 2008 the Google Maps have started their services in India, and they used to because GPS was not that much in use in the civil areas at that time. So they used to triangulate the location through mobile towers, and the location used was like it will fluctuate from one place to another whenever somebody was traveling. When the in 2010 only the GPS was used by Google Maps, and then again just because it was very new technology to be used by Google Maps then, so the maps were good, but then again there was some issue with the accuracy of the location, and now it has been solved to quite some let's say uh, good results now after the 15 14 years. We are using it very efficiently, but again some problems are there still. We read those problems in newspapers one day or the other. So natural resource management, and this is very important uh, because whenever I teach in my class, we start with our discussion with this topic only. So, if you've read the Survey of India, Geological Survey of India, all these establishments were started in India in the 1850s and 1860s, and so all of these establishments were used to map India, but not just only India. Now the Indian subcontinent, we can say that. Right? In those times, India was very huge, so almost the Indian subcontinent was mapped and managed by these establishments so as to know whatever natural resources are available in our country, and the British can easily take them from our country to theirs for their own products of industrial revolution. That those were factories. They took iron ore, bauxite, coal, each and everything, whatever natural resource were available in our country. You can see, if you want, you can see the railway network map of India, and all the major trunk lines of railway network are available in the places where natural resource is in abundance. So natural resource management started very early, even before the computers were there by British, and it is quite GIS is quite helpful in that as well. Earlier it was done manually without computers. Now it is done through computers. Mineral exploration, yes. Again, GSI has been using uh, GIS very efficiently for quite some time now. Uh, they use their probes to dig down deep beneath the surface, on land surface as well, in the ocean as well, and they monitor the logs, whatever minerals are available beneath the surface of the earth. They maintain the logs. Logs means data sources, and they use GIS to maintain those logs, data logs, and use those data logs for exploration very efficiently. Banking sector is using GIS again. uh, this core banking system, CBS system, it is using GIS for various purposes. UPI is done these days. UPIs, credit cards, and what we call is plastic money is, and plastic, plastic money as well as this tech money, we can say UPI and all are tech money. These are used in today. I read in the newspaper that daily transaction through UPI is reached almost 90 lakh crores per day, or 90,000 crores per day. So managing and monitoring these transactions with their locations is very necessary for the integrity of the banking system. So these are all done through GIS only. Taxation again, digital taxation. Bangalore is having land records fully digitized, and they are taxing, like property tax is being collected through GIS based on the area of the land being utilized by a particular person, like house tax. So, how much is the surface area of the house that is being occupied by a person? They are monitoring, rather calculating it through GIS, and they're taxing it accordingly. Land, even these revenues collected from farmers, it being efficiently managed through GIS in many areas. Uh, I remember a case in Pune. There was some problem with a farmer and some uh, insurance company or something. So the GIS and remote sensing came to the rescue to calculate the actual cultivated land so as to receive the money from insurance after some issue which damaged the crops, standing crops. Land record management, so it is being done in UP as well. Bihar, I don't know, but UP it is being created. Land records are being digitized. They are being mapped. Maps are already there, but the issue is that the projection system in which the maps are being kept, these are different for uh, each one is having its own references and they are using different systems so as to create the maps. So this issue is there. The projection system has, or rather, references have to be standardized so as to create a seamless chain of maps to represent the whole area. So this thing is being done. The land records are being digitized in India, and they are being used so that the frauds in land sale and purchase can be stopped. In situations of these
अपने आएंगे
ownership issues can be checked. Supply chain management again. Companies are using this. The companies like Walmart and the likes are using GIS for their supply chain management. Whatever the goods are required at what place. Uh, Even our Reliance is using this for these petrol pumps. They know which petrol pump requires petrol or diesel if the stock is being utilized early. They will get to know what all petrol pumps need petrol in what time. So they send their tankers likewise in a likewise manner, so that no petrol pump remains shut for supplies because of uh, uh, these that they are not able to manually see whenever the stock will be used up. So they use GIS for maintaining efficient supplies at each store or at each outlet, so as to so that the business is not closed for any time. And the last one is defense and military. This one is my favorite. We've been using GIS in this since very early. Even in First World War, Second World War, they were used. In the case of India, we have used GIS in Kargil War. Each and every op which has been carried out by this government in 2014, 16, 19, and the latest one is of Sindhu. We can, if you want, we can discuss these because these are because I must say that all these technologies, be it GIS, be it remote sensing, or be it any even survey, these are all developed by the countries for their armies, and then these were used in civil use at a later date. Even GPS, if we say, US was using GPS since 1960s, and they released it for marine purposes, for shipping purposes in 2000, and for the rest of civil use in 2010. So see, they used it, kept it secret for themselves till 50 years. Then only they released it for civil use. So each technology, even remote sensing, the earliest was like uh, this aerial photography part of remote sensing, which was used in Second World War. Cameras were mounted on airplanes, and they were flown over the enemy territory so as to monitor what is the movement of the troops of the enemies, and they can be checked, and then the results of the work can be affected in their favor. So these were efficiently done in Second World War, and then later each and every country used these kind of technologies for themselves. Even we have been using these technologies in our country. Talking about Op Sindhu, uh, the whole operation was on GIS only. They were monitoring whatever platform enemy country is using for against us, and they were monitoring. They were querying what is the size of the platform. Then they were making decision what uh, response, what should be the level of response from us so as to neutralize the platform, and accordingly we had done that. So Op Sindoor is my favorite in this case. It is a perfect example of GI use of GIS in army purposes or military purposes. Uh, in Kargil, earlier we were having heavy casualties. Then came the Bofors. Bofors, uh, in the start, they were not uh, giving us the uh, this results very effectively. Then again, the GS was used. Bofors were realigned as per the GS study, and the results in a night they changed the result. The GS study changed the result. So the army has been using GIS like anything for quite some time now. Fleet management system can be. I have not written it here, but it is there. Various transport companies are using fleet management system for themselves, GIS-based fleet management system, so as to make their the system efficient. Fuel consumption is less, revenues are more. Even if any one of you have used roadside assistance services provided by various automobile companies like Mahindra, Tata, or the Maruti or something. This RS is only GS based. Whenever there is some issue with the car and you raise a flag, your location is transported to the GS platform, and they send the assistance in very swiftly and very efficiently in very less time. So these are all the applications of GIS which are being used these days. Election Commission is using GIS. They are generating maps. Attribute data is the result of the elections. Delimitation Commission of Election Commission, they've used GIS to retransform the constituencies based on the population. Many, even this what we call NSSO, National Sample Survey Organization. This is using GIS for various studies. So, if you can, criminology, police department is using GIS to study crime and how they can be checked. A very fine example is of Bastar district of MP. Their GIS with feeds from geotagged feeds from uh, cameras were used against this Naxalite movement to check the Naxalite movement. Live feed was given from geotagged cameras, and they were analyzed on a GIS, and the movement of Naxalites were monitored through uh, GIS, and it was very helpful in checking the Naxalite movement. So these are all examples. One more is this uh, tourist. tourism was one of the very first use in civil areas in India. Uh, uh, Tourists coming from various countries were given PDA devices with buttons and maps of the locations they want to visit in India. It was in like early 2000s and late 1990s. It was being used, and it was very helpful for them. So thank you. This was the presentation. Jitendra, Jitendra, are you there?
Yes, sir.
Ah, so presentation is over.
So, thank you, Ruchin sir, for your presentation. It was very helpful and very organized presentation. So, I must, dear partisan, if you have any queries regarding GIS, you can ask to Dr. Ruchin Agrawal. Sir, one question has came.
Please.
Two database are in different projection. How could it bring to the common system?
Sorry, I missed the question. Please, can you repeat? Hello, are you there, Jitendra? Jitendra, are you there?
Ruchin sir.
Ah, if the database are in different projections, how would it bring to a common system? The projection system, GIS has got this functionality that projection systems can be changed. If they are georeferenced maps, the projection system can be changed from one system to the other. And there is a full library of projection systems available in GIS.
Okay, sir.
Changing into a common projection system, both the database can be merged and can be used simultaneously.
Sir, one question from my side, sir. What are the research scope in this GIS?
The research scope, it is endless. Now the ages of GIS only. Actually, when I started, it was a very nascent time. Now it is developing, and it has already developed, and it is in a very developmental stage. Uh, After the advent of AI, now research is like anything. You can do any research in using GIS, because GIS is a मैं तो अगर हिंदी में कहूँ तो हम GIS को नमक कहते हैं. आप कोई भी सब्जी बना लो, नमक के बगैर नहीं बनेगी अब.
Okay, sir. So one question from the audience. A few questions are there. Mr. Pankaj Kumar has asked practical example of spatial data and non-spatial data. Are there some practical examples of this spatial
There
data?
are many. There are many. For example, uh, what place are you sitting, Pankaj ji? If I may ask.
Spatial data and non-spatial data.
The which place are you sitting, Jitin?
Yes, sir.
Which place are you sitting? कहाँ पर हो आप अभी?
Uh, I'm in Bihar, sir.
बिहार ना? Which city?
Buxar, sir.
So Buxar has got some latitude longitude, right?
Yes, sir.
उसका कोई latitude longitude होगा ना बक्सर का, जहाँ आप बैठे हो.
Uh, that I don't know. I have to Google it.
Yes, sir.
अरे
Yes, sir.
है ना, होगा ना.
Longitude.
तो ये स्पेशल डाटा हो गया. जितेंद्र जी, आपकी एज क्या है?
Sir, around 32,
हाँ, तो ये नॉन
33.
स्पेशल डाटा है. पंकज जी, आई होप आई एम क्लियर.
Around 30 to 33, sir.
हाँ,
Yes,
तो
sir. Yes,
आप
sir. This thing.
आपकी एज जो है वो नॉन स्पेशल डाटा हो गई. आप जहाँ बैठे हो, दैट इज स्पेशल
Sir.
डाटा.
Okay, sir.
Any data where
So
you
there's
can,
a breakage in your voice, sir.
I don't know why it is, but network is fine. I'm audible now. Jiten ji, am I audible now?
Yes, audible, sir.
Okay, thank you. We can, Ravi Shankar ji, we can calculate volume of hazard like landslides effectively. No issues with that.
Uh, okay, sir.
Calculations can be done very easily in GIS. लैंडस्लाइड से याद आया मेरे गुरुदेव एम एम पी आर सेक के डायरेक्टर से रिटायर हुए हैं वो काफ़ी समय पहले और वो नॉर्थ ईस्ट में आर्मी के कैंप में थे और उनसे पूछा जा रहा था
Okay, sir.
कि आर्मी वाले एक वहाँ पर बिल्डिंग बनाना चाहते थे तो उनसे पूछा कि सवाल बिकॉज ही वाज अ जियोलॉजिस्ट एज वेल माय गुरुदेव सो ही वाज आस्क्ड कि हम यहाँ बना सकते हैं कि नहीं बना सकते बिल्डिंग तो उन्होंने कहा मुझे मैप दिखा दीजिए आप एक बार उन्होंने मैप देखा कहते हैं ये लैंडस्लाइड प्रोन एरिया है यहाँ मैप ये बिल्डिंग बनाना सही नहीं रहेगा एंड
Okay.
ये बात करके वो
Sir,
लोग सोए और अगले दिन सुबह
sir,
लैंडस्लाइड आ
there is
गया
a sir, there is a large audience from South India, sir, so they
ओ
might not be able to understand
ओ सॉरी
Hindi.
सॉरी सॉरी ओके should I repeat this in English or is it fine?
Yes, sir. It would be helpful for them.
Oh, so my Gurudev was in an army camp in Northeast, and he was asked by the general there, so can we make a building on a particular parcel of land there? So my Gurudev said, "Let me see the map first." And after seeing the map, he concluded that it is a very landslide-prone area, and will building would not be a good idea on that parcel of land. So after this discussion, they went for sleep, and the next day, the landslide on very particular land was there. The whole land was affected by landslide. So this study was done not on computer but on maps, but was a very fine GIS study. If you have got knowledge of a particular uh, area and supplemented with maps, you can carry out decisions which are very effective and very fruitful.
Okay, sir. One more question has came from audience. Dr. Ravi Shankar is asking, can we calculate the volume of hazard like landslide effectively?
I've told that him it can be done. And again, Dr. Ravi Shankar has he asked depth. Yes, depth can be calculated. GSI, I've told GSI, they've got ships. Uh, they probe the ocean bed in the Bay of Bengal and Indian Ocean and Arabian Sea as well, and they calculate depth as well. And to know how to calculate depth, sounding rods are there. If you are in
Yes, sir.
shallow area like a river or something, so you can use sounding rods to calculate depth, and this data can be
Yes, sir.
transferred to GIS very effectively.
Okay, sir. One more question
Um,
from Pankaj Kumar is asking application of GIS for land settlement issues in Bihar. Can it be done?
yeah, it can be done, but for that you will have to create the whole land records. We will have to digitize the whole land records, and the attribute data should be created effectively. Then only this can be done, and it is a very huge task. Even at a village level, it is a very huge task. Forget about
Sir,
district
it
level.
is biggest issue in the Bihar, sir. Biggest issue.
Everywhere, everywhere, everywhere. Not only in our country, everywhere. The land issues with China as well. How can we sort that out? It is everywhere.
I
We have land
think
issues with Bangladesh. We have land issues with Nepal. We have land issues with Bhutan. We have land issues with Pakistan. So
yes, sir. Yes, sir.
it is a universal issue. Everywhere it is there. Not only in our part of the country, but
Yes, sir.
other
Practically
part as well.
ये काफी टफ हो जाता है सर.
It is. It is. That's why we are having wars, na? If it has not been there, there would not have been any war.
Yes, sir, one more question has came. If the shape file is not correctly aligning with the base map, how could we fix it?
This means your shape file has not been georeferenced effectively. Please re-georeference the shape file, and it will be better to check the ground truths on a large scale. Then the problem will be sorted out easily, I think.
Okay, sir. So one more question from my side, nowadays we are listening, means we are in EV are coming in more news like Tesla and self-driving vehicles.
So what?
So there also GIS is there also GIS we can use
Everything.
GIS.
It is based on GS only.
Okay,
Without network analysis, Tesla would work,
okay,
and it bring Tesla to India and bring that car in any city center of any place in India. It will not be
okay.
able to find the route. It will fail because network analysis won't be helpful in heavily crowded, heavily populated city centers of our country.
So we have our own satellites, or sir, or are we using, sir,
Ah,
American
no, 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 no,
geo?
no, no. This mistake was done in Kargil War. Actually, GPS has got an error code, which is being induced by America, so that you won't get your location perfectly. Error code is they induce error code, and during the Kargil war, they have encrypted the whole locations which were being provided by the GPS through error code, so that we were not able to get the location precisely. After that, India made its own navigation system. We have launched our satellites. We have got our own navigation system. This time, Operation Sindoor, if, if you are following that, we have used that quite effectively.
Okay, that means GIS application in defense also is very important.
Array, GIS started in defense only, na? What I told you.
Okay,
The
okay,
major research in GIS is being done by the defense only.
oh, okay, sir.
अभी तो हम सोच भी नहीं सकते जितेंद्र जी क्या क्या हो रहा है.
Yes, sir.
आप कभी हमारे साथ बैठिएगा तो हम
Audience,
बताएंगे.
you can ask some more question if you like, or else we can conclude this session. If there is any more query from the audience. Okay, I think we can conclude this session. Thank
Okay.
you, Dr. Ruchin Agrawal, sir.
Thank you, Jitin ji, for having invited
Thank
me.
you for this kind and very informative session. Uh, we are blessed to have you on this session as a speaker.
Pleasure is on mine.
Okay, sir.
Thank you. Thank you all.
So, मेरे में था.
Shall I leave?